Hello, it's Ryan here from RLF Vacuum Cleaners in Lakenheath, and in today's video I'm going to be talking about STC1000 temperature controllers again. This is the temperature controller that I reviewed in a previous video, and I noticed today that it has packed up, it ceases to function, the display is dead, that's also taking no current, so it's not actually using any electricity, it's completely dead. So, like all good things, I bought a backup anyway. I bought a couple of these, so I got a backup. So now I'm going to investigate why it has failed and hopefully be able to fix it. Now, for anybody who didn't watch the last video, this here is the mains voltage 110 to 220 volt AC version. And again, we've got it connected up to power. It's not connected to the mains power. It doesn't actually need mains voltage to work. That might be the issue. It might need mains voltage, but anyway, we've got it connected up. It's completely dead. Nothing happens. So what we're going to do is we're going to strip it down, take it all apart, and we'll go through some fault finding. So I just disconnected the crocodile clips. To open these up, these are nice and simple. You get your flat bladed screwdriver, gently prise on the tab so it pops off. Gently prise on the tabs so it pops off. And gently wiggle it, the front comes off. And you've got front circuit board like that. You just pull it out gently. In fact, I'll probably undo the temperature, or pull the temperature sensor out first gently. And pull that out like so. I've just attached a couple of wires for testing purposes. So this is the circuit board. Now, what would have failed? There's not actually a lot on these circuit boards to fail. Nothing looks, give a bit of a close up. Nothing on that side looks too bad. Nothing on this side looks burnt. Nothing to burn or damaged or missing or anything like that. Mind you, that diode there is a bit skew, but that's the diode to prevent the EMF spikes, so when the coil gets de-energized. So this isn't going to affect the running of it. Well, it might be. It's possible that it's not connected to an EMF spike, blew the controller up, but I think we're more likely to have an issue with a sort of mains input or the input circuitry. But we'll start off at the mains input. We'll check for continuity, make sure everything's connected up, check the diodes, check this little chip, and we'll go from there. So we'll just zoom you in. The problem is with this, when you zoom in, it doesn't lose a lot of its focus. Let's see if we can get a bit closer. So first of all, I brought in the meter here. This is about as zoomed in as I can get without sort of losing too much. So we'll start off on continuity. We're going to check to make sure we've got continuity between different things. So here, yep, here, so yeah, we've got continuity on the input. So what we'll do next is I'll swap that over to diode test, and we'll check these two diodes. Yes, we're getting about 0.5 drop, which is pretty good. And then we go on to the other one, get about 0.5, 0.6 drop. So what we'll do is we'll swap that over, and we should get nothing. But again, we get nothing. We swap that over, get nothing. So we started off with the input, so we've ascertained that yes, we've got continuity. Now I don't know if this meter's good enough, but can we get continuity through all of it? Oh wait. Now, yeah, so we've ascertained that we've got continuity from the mains input to this little chip. Now, checking this little chip is going to be a bit of an awkward one. I think the best way would be to power it, but we're going to use a little bit of low voltage. Low voltage mains, so if we go right to that one there. And we'll bring in our multimeter, we'll put that onto voltage. So from here to here, we get in 20 volts. We zoom in on this bit. Yeah, so we get 20 volts on the input. What about the output now? This is a non-isolated supply. So if we go from there to there, jump up and down a bit. Never a good sign. I'll get that up on my camera. Because this is a non-isolated supply, the neutral is linked through. So if we go, see we're jumping up and down. We're not getting a good stable supply, are we? Now what we'll do is, I've got another one of these. We'll just double check because the data sheet for that chip is a bit limited. So what we'll do is we'll bring in another one. So what I've done is I've got another one out the case, put some wires on it. And we'll just grab a we'll grab this little plastic case. Don't want to short it out on any rogue pieces of soldering on my bench. So what we'll do is we'll connect this up. You can see the display is lighting up. And what we're going to do is I'm just going to measure the output, because I think we should be getting 5 volt out of this chip. So connect that to there. Don't know how well the camera is going to pick this up. You can see we're getting 5.3 volts. So that leaves us with two schools of thought. Either this chip here is faulty, or there's some sort of short or something pulling the voltage down and causing all the issues, probably causing that chip to shut down. This chip is unproven, but what we'll do is we'll bring the old one in that's broken. We'll double check everything, make sure there's no shorts, any diodes or capacitors failed or anything like that. If not, we'll have to replace the chip. I've got some replacement chips which I'm doing some experimenting on, so that's not a problem to put a new chip on. So yeah, we'll bring the new one in back in a moment. So first of all, we'll check this inductor. What we're getting about 13 ohms on the inductor. Pretty good, it's not open circuit. And on the working one, we're getting 12.7, so yeah, that's pretty close. So after that inductor, where does it go after the inductor? After the inductor it goes to capacitor and some links. Now, unfortunately this meter doesn't do capacitance, so I have to get another one quickly. So using my TIS E217, I'll put that on capacitance. So here we have the original one, and we're getting oh wow, never a good sign. Oh wow again. On the good one? What do we get on the good one? So on the good one we're getting 1000 UF. Now, 1000 UF, camera's not showing up very well because there's capacitors in circuit or other things which add capacitance. But the fact we're getting OL on this one, or nothing on that one, isn't a good sign. So what we'll do is we'll fire up a soldering iron, we'll take this out of circuit and test it, and then after that, capacitor, and then got a little 0 ohm link, then got a capacitor there, then got another 0 ohm link there. So we'll check all these resistors and 0 ohm links and capacitors as well. So I don't think there'll be anything wrong with them, but we'll check them anyway. So we'll put that onto resistance. This one had lead resistance of about 1.6 ohms. Now again, you shouldn't really test these in the circuit, but again, OL on that. Again, on this one, yeah. Yeah, because on that top one we get 1.6. Yeah, some 0 ohm links are good. What about this resistor, which is a 102, which is 1k, 1k. What else we got on this board? Got another 1k. Okay, one. I think we're going to zoom in a bit. Got another one, 103. Let's give that one a test. Tiny little one there. It's 10k. 10k. And to quickly pause, let's put the camera on charge because it went flat. So I conducted a load of tests, and the only real differences I can really see when we test it properly, really dig the probes in, is either this chip's got an issue or this capacitor's got an issue. Everything else seems to be acting as it should. So I'm going to fire up a soldering iron, desolder this capacitor, take it out, see what it's measuring at, and if that doesn't work, I might try a new capacitor. If that don't work, we'll try a new chip. If not, it's probably going to be a processor issue, and again there's probably not much I can do about that. So yeah, once the soldering iron's warmed up, we'll get this capacitor out and we'll go from there. So using my special electrical tweezers, which I've probably made a video about, but if not I probably will in the future. Ooh, you can see we're getting about 210 UF, and this is a 220 UF capacitor, so that's alright. So I'm gonna check the board again, check to see if everything seems to be working alright, check a bit of continuity. If not, we're gonna have to replace that chip. So yeah, having checked it all over, I can't seem to everything seems to be working alright. Continuity, connection, everything seems to be alright. So what we're going to do is we're cleaning up these pads here, put that capacitor back in. We'll then fire up the hot air gun, take this chip off, and see what changes. So yeah, back in a mo. It's awkward to do with a camera in the way. Oh, all done. Yeah, it's a bit fiddly with the camera in the way, because you've literally just got that much room. But yeah, a bit of desoldering braid like so. I'll put the capacitor back in, take a note of polarity. With the capacitor, this side's the negative, and on the side they clearly marked out the negative. Put that through like so. So we put that in, dab a solder on. Now unfortunately I don't have my really thin solder, I've only got the big stuff, so literally just a quick touch, that'll be it. Well, that's all soldered back up. We'll try just for a laugh, see if my fiddling around has made it work. I suspect probably not. I'll give it a whirl. We don't want to create more work than we have to. So we'll connect that up. Like so. No, it's still dead. So what we'll do is we'll fire up a hot air station, we'll take that chip off, and we'll go from there. So by bringing in the hot air gun and just gently warm this up, I'm bringing my tweezers and I'll just pick it up. Turn the air off a bit. Not quite. Put that off like so. To be fair, that looks good. So what we'll do is we'll do some quick testing again. It's certainly behaving differently now that chip is off, which is a good sign. So what we'll do is we'll clean these pads out. We've got a blob of solder paste on and we'll try a new chip. Right, so what I've done is I cleaned up the pads, put a quick blob of solder paste on, new chip on, and what we're going to do is we're going to use the hot air gun, warm it up till the solder paste melts. Just drop the temp slightly. And drop the temp slightly if you don't want to do it too hot and damage the chip. I'll turn the air down a bit for that. So we'll bring the hot air gun in. I'll just gently warm it up. Solder paste is some magical stuff. When it finally goes. Alright, I see it's starting to go now. Oh, that looks like everything's reflowed on there. We'll let that cool down. And you can see, I don't know whether it can come up on the camera. That's actually reflowed pretty well. This side looks like we've got a little bit of a short. We can fix that with just a quick dabble on the soldering iron. And after that, I think we're ready to go. Yeah, I've probably got that short because I probably got a bit too much on, but again, solder paste is a bit of a learning curve. You want to put enough on that you get a good joint, but not too much that you get a short on. So I just gave that a quick going over the soldering iron. You can see when we remove that little solder bridge. It doesn't matter so much to them to link together, but it's just good practice to make sure your solder joint's good. The camera is absolutely rubbish at this close-up stuff, but everything else looks good. Got nice joints on there. Yeah, we'll fire. Hello, Brian here. A quick update on this temperature controller board. That one was a bit of a pain in the arse, but I've managed to get the old board, or the blown up board, working on the new one. This is actually quite an in-depth job. What we found was this little chip had blown, but the only way we knew that was going to be blown is, or we replaced it and it made no difference. So then we started investigating and we found a couple of shorts. This problem had faults on faults on faults. So we found some shorts and we found some components damaged. But one of the ones we couldn't do anything with was the screen. This is the back of the screen. The power for the screen is short circuit. So I'm not quite 100% sure what happened. Did this voltage regulator break down that high voltage through and it blew the screen up? It also blew several other components up. You can see all the soldering bits we resoldered. But anyway, we're going to find this short components. Was to literally take every single bit off one at a time, break it down. And this is why the screen doesn't have its 7-segment display on it anymore. 7-segment display is alright. It's actually the chip on here has actually gone short. So once we removed it all, breaking it down, starting it all putting it back together again one by one, we could fix all the faults until eventually we got it up and running again. So yeah, would I recommend the mains voltage one? Hopefully this is probably a one-off, but well, I hope it's a one-off anyway, but we'll find out. We'll put this back into service again and we'll see if it blows up again. If it does blow up again, then I'll probably recommend that you stick to the lower voltage ones. The lower voltage ones use a AMS linear voltage regulator, which is a lot better. I've never ever seen one of them fail. They're pretty reliable. They're good for about an amp. These chips are only good for 200 milliamps. So yeah, we actually got up and running. So we got it fixed. We got the actual main board fixed. So that's good. It's just a screen. So I'm not quite sure if you'd be able to buy one of these screens separately. The problem is these chips don't actually have any numbers or anything on them. They're just blank. So isn't really worth the effort of going through and trawling through, finding what they are and ordering them. Probably not. So yeah, if you have a problem with this one, we got a good base, a good, yes, we've got a whole complete one, and we've got a good base. So this base one might come in handy for some bits in the future. Chances are, if this one's going to fail, I'm probably going to blow the screen up again, or blow the chip up for the 7-segment display. That's all the clever stuff. So yeah, I just thought I'd update you. One of the things I would like to say is tool of the day. Goes to this little dispenser. I bought some solder paste, and these people had a little option for one of these little dispensers. The problem is with solder paste is it's quite thick and gloopy, and if you use a syringe, it's hard work and you end up putting too much on this. You can get sort of very precise, finite adjustments with a little squeeze. Good little tool these are. I did look them up. I think they're not expensive, about £4 or £5 I think to buy one of these. Jolly handy. I'm glad it came because I was doing a lot of, when it came to putting things back on again, this came in valuable for doing lots of little blobs here and there. And of course, my Sealy hot air gun, brilliant little tool. Hot air makes the job so much easier. So yeah, this is how I fix this one. It's not really a complete fix as the screen is dead, but we actually got this up and running. So yeah, shame I didn't film it all. Problem is, as I was filming, I ran out of memory and my phone went funny and I lost a lot of footage. So there's a bit of a gap, but I thought I'd update you. So yeah, thank you very much for watching and goodbye.